Hi, Generals. It's General time again. Remember all of our activities this week. Remember to participate in homecoming and dressing up. Remember to appreciate a teacher today, as well as remember the strategies and steps you said you would take to end bullying. This today we're going to concentrate in on what makes a good scientific experiment. Remember to pull out your information from yesterday so that you won't have to rewrite a lot of the same information. Okay, we're going to start off by reading an experimental scenario. Here's the scenario. As I read it, write the scenario down. A biology lab group compared the effect of different aged grass compost on bean plants. Because decomposition is necessary for the release of nutrients, the group hypothesized that older grass compost would produce taller bean plants. 3 flats of bean plants, 25 plants per flat, were grown for 30 days. The plants were fertilized as follows. Flat A had 450 grams of 3-month-old compost. Flat B had 450 grams of 6-month-old compost. And flat C had 0 grams of compost. The plants received the same amount of sunlight and water each day. At the end of 30 days, the group recorded the height of the plants. If you haven't finished writing down the scenario, pause the video until everyone has written it down. Okay. As you will recall from yesterday, a hypothesis is a prediction about the relationship between variables that can be tested, or basically it's a guess on what's going to happen. So you don't need to write the definition of a hypothesis down, but let's write hypothesis example, meaning according to the scenario, if older compost is applied, then the plant growth will be increased. That's our hypothesis in this experiment. Write another hypothesis for the same scenario. Pause the video until everyone has written a new hypothesis. Okay, we didn't talk about this, an independent variable. The variable that is purposefully changed by the experimenter. For example, age of the compost applied. Write an independent variable based upon your hypothesis you written earlier. Pause the video until you have created a new independent variable. Make sure on the example scenario you circle where it talks about age of compost applied and write independent variable so you know that's what it means. Dependent variable. It's the variable that responds. So for example, the height of the bean plants. On your hypothesis, or based on your hypothesis, write what the dependent variable would be in your experiment. Again, on the original experimental scenario, circle where it talks about the height of the bean plant and write a note that that's the dependent variable. Pause the video until everyone has completed that process. Constants. All factors that remain the same and have a fixed value. In the example of the scenario, the amount of light and water would be constants. Write a constant or multiple constants based upon the hypothesis and the dependent and independent variables that you're creating in your experimental design. Pause the video until everyone has written this information, including circling where it wrote in the experimental scenario, the light and water, and labeling it constants. Control. The standard used for comparison in the experiment. So, example, plants in flat C receiving no fertilizer. That's the control group. Again, circle where it is flat C and circle and write the words control. Now, on your experimental design that you're creating off of your hypothesis, write a control based upon yours. Repeated trials. The number of experimental repetitions, objects or organisms tested at each level of the independent variable. So for example, 25 plants in each flat represents 25 trials. Based upon your trials, and again it could be very similar to the experimental design scenario that's given, write the number of your repeated trials or come up with how many you would have in your design. Pause the video again until everyone has not only marked on their experimental design scenario what represents a repeated trial, but also wrote their own number of repeated trials. Okay, now you kind of went through and wrote the steps of your own experimental design. Now let's kind of like consolidate that and write it as a summary. So an experimental design diagram could be summarized like this. You would have an independent variable, dependent variables, constants, control, number of repeated trials, an experimental title, and a hypothesis. Pause the video until everyone has wrote these elements of what would be contained in the design. Okay, here's a diagram of an experimental design. It's one example of a design that you could use. Basically, pause the video and write down the experimental design diagram on your paper. Unpause the video when everyone is done. Okay, now looking at the information that you just wrote down, complete your own experimental design diagram based upon any kind of current problem. Review your notes on the scientific method you took yesterday, as well as the notes you just did today on creating an experiment to help you. But maybe you need a little inspiration. I don't know if you know, but Google has a science fair each year. It launched its first year this past school year in the 2010-2011 school year. And the top 3 finalists were actually girls. This is a video of them explaining their experiments. We're just going to watch a couple of them. If you want to watch them all, go to the notebook file and you'll be able to open up the entire video. Let's take a listen.
If you were going to a restaurant and wanted a healthier option, which would you choose, grilled or fried chicken? Now most people would answer grilled, and it's true that grilled chicken does contain less fat and fewer calories. However, grilled chicken poses a hidden danger. The hidden danger is heterocyclic amines, specifically phenylmethylamidazopyridine, or PHIP, which is a mutagenic or carcinogenic compound. A carcinogen is any substance or agent that causes abnormal growth of cells, which can also cause them to metastasize or spread. They are also organic compounds in which one or more of the hydrogens in ammonia is replaced with a more complex group. Studies show that antioxidants are known to decrease these heterocyclic amines. However, no studies exist yet that show how or why. These here are 5 different organizations that classify carcinogens, and as you can see, none of the organizations consider the compounds to be safe, which justifies the need to decrease them in our diet. Now, you might wonder how a 13-year-old girl could come up with this idea, and I was led to it through a series of events. I first learned about it through a lawsuit I read about in my doctor's office, which was between the Physicians Committee for Responsible Medicine and 7 different fast food restaurants. They weren't sued because there was carcinogens in the chicken, but they were sued because of California's Proposition 65, which stated that if there's anything dangerous in the products, then the companies had to give a clear warning. So I was very surprised about this, and I was wondering why nobody knew more about this dangerous grilled chicken, which doesn't seem very harmful. But then one night, my mom was cooking grilled chicken for dinner, and I noticed that the edges of the chicken, which had been marinated in lemon juice, turned white. And later in biology class, I learned that it's due to a process called denaturing, which is where the proteins will change shape and lose their ability to chemically function. So I combined these 2 ideas and I formulated a hypothesis, saying that could possibly the carcinogens be decreased due to a marinade, and could it be due to the differences in pH? So my idea was born, and I had the project set up in a hypothesis. So what was my next step? Well, obviously I had to find a lab to work at because I didn't have the equipment in my school. So I thought this would be easy, but I emailed about 200 different people within a 5-hour radius of where I lived, and I got 1 positive response that said they could work with me. Most of the others either never responded back, said they didn't have the time, or didn't have the equipment and couldn't help me. So it was a big commitment to have to drive to the lab to work at it multiple times. However, it was a great opportunity to work in a real lab, so I could finally start my project. The first stage was completed at home, which consisted of marinating the chicken, grilling the chicken, massing it, and preparing it to be transported to the lab. The second stage was completed at Penn State University main campus lab, which is where I extracted the chemicals, changed the pH so I could run it through the equipment, and separated the compounds I needed from the rest of the chicken. The final stage is when I ran the samples through a high-pressure liquid chromatography mass spectrometer, which separated the compounds and analyzed the chemicals and told me exactly how much carcinogens I had in my chicken. So when I went through the data, I had very surprising results because I found that 4 out of the 5 marinade ingredients actually inhibited the carcinogen formation. When compared to the unmarinated chicken, which is what I used as my control, I found that lemon juice worked by far the best, which decreased the carcinogens by about 98%. The saltwater marinade and the brown sugar marinade also worked very well, decreasing the carcinogens by about 60%. Olive oil slightly decreased the PHIP formation, but it was nearly negligible. And the soy sauce results were inconclusive because of the large data range, but it seems like soy sauce actually increased the potential carcinogens. Another important factor that I didn't take into account initially was the time cooked. And I found that if you increase the time cooked, the amount of carcinogens rapidly increases. So the best way to marinate chicken, based on this, is to not undercook, but definitely don't overcook and char the chicken, and marinate in either lemon juice, brown sugar, or salt water. So, based on these findings, I have a question for you. Would you be willing to make a simple change in your diet that could potentially save your life? Now, I'm not saying that if you eat grilled chicken that's not marinated, you're definitely going to catch cancer and die. However, anything you can do to decrease the potential risk of carcinogens can definitely increase the quality of lifestyle. Is it worth it to you? How will you cook your chicken now?
I'm Sri Bose. I was the 17-18-year-old age category winner and then the grand prize winner. And I want all of you to imagine a little girl holding a dead blue spinach plant. And she's standing in front of you and she's explaining to you that little kids will eat their vegetables if they're different colors. Sounds ridiculous, right? But that was me years ago. And that was my first science fair project. It got a bit more complicated from there. My older brother, Pinocchio Bose, spent hours of his time explaining atoms to me when I barely understood basic algebra. My parents suffered through many more of my science fair projects, including a remote-controlled garbage can. And then came the summer after my freshman year, when my grandfather passed away due to cancer. And I remember watching my family go through that and thinking that I never wanted another family to feel that kind of loss. So, armed with all the wisdom of freshman year biology, I decided I wanted to do cancer research at 15. Good plan. So I started emailing all of these professors in my area asking to work under their supervision in a lab, got rejected by all except one, and then went in my next summer to work under Dr. Basu at the UNT Health Science Center in Fort Worth, Texas. And that is where the research began. So ovarian cancer is one of those cancers that most people don't know about, or at least don't pay that much attention to. But yet, it's the 5th leading cause of cancer deaths among women in the United States. In fact, 1 in 70 women will be diagnosed with ovarian cancer. 1 in 100 will die from it. Chemotherapy, one of the most effective ways used to treat cancer today, involves giving patients really high doses of chemicals to try and kill off cancer cells. Cisplatin is a relatively common ovarian cancer chemotherapy drug, a relatively simple molecule made in a lab that messes with the DNA of cancer cells and causes them to kill themselves. Sounds great, right? But here's the problem. Sometimes patients become resistant to the drug. And then years after they've been declared to be cancer-free, they come back. And this time, they no longer respond to the drug. It's a huge problem. In fact, it's one of the biggest problems with chemotherapy today. So we wanted to figure out how these ovarian cancer cells are becoming resistant to this drug called cisplatin. And we wanted to figure this out because if we can figure that out, then we might be able to prevent that resistance from ever happening. So that's what we set out to do. And we thought it had something to do with this protein called AMP kinase, an energy protein. So we ran all of these tests blocking the protein, and we saw this huge shift. I mean, on this slide, you can see that on our sensitive side, these cells that are responding to the drug, when we start blocking the protein, the number of dying cells, those colored dots, they're going down. But then on this side, with the same treatment, they're going up. Interesting. But those are dots on a screen for you. What exactly does that mean? Well, basically, that means that this protein is changing from the sensitive cells to the resistant cells. And in fact, it might be changing the cells themselves to make those cells resistant. And that's huge. In fact, it means that if a patient comes in and they're resistant to this drug, then if we give them a chemical to block this protein, then we can treat them again with the same drug. And that's huge for chemotherapy effectiveness, possibly for many different types of cancer. So that was my work, and it was my way of reimagining the future for future research with figuring out exactly what this protein does, but also for the future of chemotherapy effectiveness. So maybe all grandfathers with cancer have a little bit more time to spend with their grandchildren. But my work wasn't just about the research. It was about finding my passion. That's why being the grand prize winner of the Google Global Science Fair, cute picture, right? It was so exciting to me, and it was such an amazing honor. And ever since then, I've gotten to do some pretty cool stuff, from getting to meet the president to getting to be on this stage to talk to all of you guys. But like I said, my journey wasn't just about the research. It was about finding my passion, and it was about making my own opportunities when I didn't even know what I was doing. It was about inspiration and determination and never giving up on my interest for science and learning and growing. After all, my story begins with a dried, withered spinach plant, and it's only getting better from there. Thank you.
For more, you can check out the video on your notebook file and watch it in full. Talk to you again tomorrow, Generals.